directions. Stop the talking. I hear Miss Tran is using her doorbell. Okay. I need everybody to stand up. If you have a backpack, temporarily put it on your desk. On your desk. It's gonna be one desk at a time. Y'all move off. Today, our arrangement in class. Push your chairs back in, because we still need to be standing.
What would you need a pencil for? No,
Someone pick up that Cheerio on the floor.
Here it is.
It's dry. Okay, so I need everybody in the front sitting in, it says a circle, but it's gonna have to be an oval on the floor, kind of close together. So we're not doing the 6-foot rule between each person, obviously. But like in a big oval, everybody, I mean, every last person. Everybody. Then scoot out a little bit. No. I've got to get in the middle. Y'all got to scoot out a little bit.
I'll get
Here's the thing. We're done with this. These four are going to have to be separated out or turned somehow because we can't have 8 desks together. It's not allowed. Okay. Got it? Okay. When I do this, you're going to have both hands on the floor beside you. So make sure you have room to have your hands on the floor beside you. Look, there's a big gap over here. Scoot out so you are equally placed. When I'm in the middle doing this, you're going to have to close your eyes. Okay, Megan, what I'm about to be doing in the room, hold on just a minute, guys. Megan, what I'm about to be doing in the middle of the room, you might be able to hear,
but I'm not going to be sitting right in front of the computer, okay? Class.
Hush, please. Remember, I have a virtual learner also. She's not in here with us. And because we're sitting on the floor, she can't see you. What did I just say? You don't listen. That's a problem. You don't listen with your feet or your ears. Okay. When I'm in the middle, perhaps you might be more perceptive if you close your eyes. Remember how we learned how our other senses get more sensitive when we close our eyes? Okay, so I'm going to go in the middle. Make sure both your hands are on the floor beside you or in front of you. Either one. I'm not going to step on your hands. I feel like I'm going to shut the door so all the things from outside the room don't disturb us. We're not talking. Everybody's eyes closed. Hands are doing slow down. No. I'm not going to hurt you. I'm in the middle. I'm not coming towards anybody. I'm standing in the very middle. What'd you feel?
Are we supposed to feel something?
Yeah.
Yeah.
Did you feel something?
I felt nothing.
You didn't feel the vibration?
No.
Yeah, you can open your eyes. What did you feel?
Vibration.
Okay. Did you just feel one vibration or did you feel it kind of more than one?
I felt the first one. I felt two. I didn't feel two.
Okay.
I felt one.
What was that?
Well, really, I felt nothing.
Okay. Can't hear multiple people talking at the same time. Sorry, I can't respond. With the first one I did, because that was a good strong stomp. Did you just feel the first, or did you feel any kind of following, like a reverberation?
Like when I feel everything.
Let me try it again and see if you guys can observe. Just concentrate on the vibration, what you feel. I'm not going to stomp on you. I'm in the middle. Stop the talking. Hands down. I'm not going to step on you. I'm in the middle. I'm at least 3 feet away from each person. You felt one vibration on that, but did you feel other lighter ones afterwards?
Yeah.
Real light ones.
I did.
Kind of like ripples on water, right? Did it feel kind of like ripples on water? They're real light, like you saw in the picture. Okay. So I'm going to try this a different time. And when you feel the vibration, hold on. Let me read this out loud. Ask students to place their hands back on the floor before stomping again. Raise your one hand and keep it raised when you feel a vibration. Okay?
If you don't feel the vibration, you put it down.
Yes. Okay.
So everyone raises their hands, closes their eyes, and feels the vibration. Keep it up.
Got it? So if you don't feel a vibration, you're going to lower your hand. Got it? Everybody understand that? So you're going to have one hand on the floor. Everybody's going to have one hand on the floor. Before I start, I'm not going to stomp on your hand. Stop saying that. This is not the time to be silly. Okay? I'm going to stomp one time. Your hand underneath your leg. That leg is dampening the vibration. Don't put your hand under your leg. Put your hand out flat on the floor. Flat. There you go. All right, everybody ready? If you don't feel a vibration, you're going to drop your hand. Okay? Most people felt the vibration. Okay? Let's try something else. Everybody, one hand up. Keep the hand up, and when the vibration, you know how it kind of has that ripple feeling, and then it goes away, doesn't it? It stops feeling. When that ripple goes away, then drop your hand. You're talking about? When you stop feeling that ripple, drop your hand. That means you're gonna drop your hand pretty fast, doesn't it? Pretty fast, isn't it? That's how much. I think it's not still harder. Okay. Yeah, this is probably like, what's the thing for doing? I think we're all tired.
What's he doing
Is that one of y'all? Is that one of y'all something? Or did-
They keep on breaking the room up to
Roll them in a bit. Yes. Okay, so do you guys think that the vibration is starting in the middle where I'm talking about? It's going outward, isn't it? Right? So if I had a big classroom and maybe had little concentric rings of people, do you think the people closer to me could feel the vibration stronger than the people farther out?
Yeah.
Okay. So do you think it would be in concentric rings like those circles we saw yesterday? So if we were to draw it, where in the middle is where I'm standing, and that's where it's strongest. Trust me, my leg would tell you that. The last kick on the floor hurt. That's where it's strongest, where the force is on the floor. And where you guys are sitting, that's where it's the weakest, right? In fact, a couple boys couldn't feel the vibration. Right? Because you guys were the hardest way. And actually, you guys were pressed up against something. And so you're kind of letting the force go through you and ground itself out in the thing that you're pressed up against. So it's kind of going through you and killing the force behind it. So have we seen this kind of thing before?
Yeah,
In water. Okay.
Jumped off the bus.
Okay, everybody, let's get up. All right. The other desk will be for Go to your desk. It's not late.
Now there's no 6 feet between me though. Now we're real cozy over here, at least for today. Okay, so what we were doing, Megan, was I was standing in the middle of the circle and all the physical kiddos that were in class were sitting on the ground around me. Apparently I was hitting all kinds of buttons on my phone. And stomping on the floor, making the Deletus below me, wonder what the heck we were doing. And the students were trying to feel the vibration and how the vibration moves through the floor. And since we're on a second floor, some of the vibration was actually going downwards. It wasn't just going out to you guys. Some of it was going down. So some of the motion, instead of going, we talked about yesterday, vibration goes side to side and also going up and down. Some of the vibration was going up and down, so we're losing a little bit of the motion that way. In fact, it was going downstairs. Or Miss Cletus. So here is the share screen on ImageMate. Here is what it's believed that a vibration, how it would travel. Okay, if we were to notice a pattern, I would be standing in the middle, not stomping on any hands, and where the students were sitting, probably about like this, because that's about as much room as we could squeak out in this classroom with all these desks in here. having 23 desks in here. That was about where you guys were. But I was losing a lot of the vibrational force through the floor itself before I set the floor. And just honestly, I'm not going to stomp real hard with my head hurting like it is. 2 people in our circle of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people. 2 people couldn't feel the vibration, but we also weren't all sitting up away from surfaces. Most of us were either leaning against the wall, leaning against the box, leaning against the chrome cart, leaning against the desk. So we were transferring some of the energy through our bodies to the thing that we're leaning against. And so we weren't able to feel all the force ourselves. We were transferring our energy right through us, kind of like we were a conduit. Yesterday we looked at a picture that looked a lot like that, didn't we? What was the picture depicting? Water, waves on water. Have you seen that anywhere else though?
Yes.
Where?
At a lake.
At a lake, where?
I saw the water. And when I went back in,
So what happened to make the lake look like that?
pressure.
What do you mean?
Like jumping in.
Jumping in
Yeah.
and splashes of water hitting it?
Uh-huh.
Or boats causing splashes of water? What else? Michaela? I'm sorry, I have hairs in my mask. When it's raining and a raindrop hitting something, hitting a puddle, right? And it causes that, ripples on water, right? What else? Caddo Lake, what was hitting the water? There's alligator fight, so they were causing ripples on water, right? So anything that causes ripples on water, like a water spout, it could definitely cause a ripple. It does look like a tornado, top of it. If you're looking from the top down. So if it's raining, raindrops fall in puddles of water. If you toss a rock in a water, can't a rock make a ripple like that? Mhm. So yesterday we heard in this book, Elephant Scientist, that vibrations ripple across surfaces like waves on water. And we go back to this picture, waves on water. Okay, ripples like waves on water. How might ripples in water be similar to vibrations in the ground?
Oh, when it flashes and it comes with movement, and it vibrates the water.
Okay, anybody else have anything to add to that?
The boat, like if you're driving a boat in the water, it makes a vibration.
Okay, so the boat can cause vibrations and make ripples. The boat is causing the vibrations.
And loud
It can
noises.
cause vibrations. Loud noises can cause vibrations and cause the water to ripple. Definitely.
I know.
How's that, Megan?
Whenever someone walks,
Uh-huh.
vibration, and when you walk in water, it ripples too. They both ripple.
Yes, they do.
When you swim too.
Okay. The answers I gave here are actually more simple than what you guys gave. What you gave was actually more eloquent. What they have here is the pattern in the drawing looks the same as the pattern in the picture.
It does.
It does.
And
But y'all's answers are more eloquent than what they gave here. Mhm. So ripples in water can create similar patterns to vibrations on land. And to better understand that, we're going to gather more information about ripples in water by investigating our new phenomenon question, the one that's up there in green. What makes water waves appear the way they do? So what makes them look like this? Water waves. Well, that's what we're going to be investigating for lessons 7 through 9, which is today, tomorrow, and Tuesday. Okay, so looking back at this picture, where do you think that ripple came from? What do you think started that ripple? Maybe a fish jumping. What else could have caused it? Kayla, what's that? a fishing rod dropping like a lure in the water.
boat?
A rock could have done it. Door's open. Just open it. Turn the knob. Turn the knob.
Come in.
Entrez-vous. Push door open.
That's Mariah.
Come on. Is there to take me out?
Mariah. Oh, someone swimming can make that.
They could. How could a person swimming do that?
Making vibration and movement. Doing
Maybe if while they're swimming, a little
wave.
bit of water flew off of them, and that drop of water hit, it could cause that, right? Okay.
And someone walking in the water. Maybe whenever you're in the water. Oh yeah.
A bubble coming up can cause that ripple. Okay. Hold on, I gotta do attendance real quick. Now my last person came in, I can do attendance. 30 minutes late. Rain could do it. Raindrop could start that. So we understand different processes could start that, right? Good thing I write down my passwords because lately I can't remember.
How many smart passwords?
Day 15 of migraine. I'm doing good to know how to drive.
What?
This is day 15 of migraine.
People don't know how to drive when they're in like this?
I threw up all my dinner last night. I threw up my lunch yesterday. Yeah, migraines are fun, yo.
It's fucking you. This is weird doing the table so easy.
Okay, so one of the comments down here is something had to drop in the water to start that ripple. It could be a raindrop, it could be a rock, it could be a fish jumping and it splashing back some water. It could be a turtle. Anything dropping water or anything else dropping in the water could start that ripple, right? Okay. So something affected the surface of the water. We can all agree on that, yes? I'm gonna put the pencil up here so you know you're not like looking at nothingness. There is something here, it's a black tablecloth. Okay, so the book wants us to think of the word disturbance to refer to the motion that creates a wave. Disturbance. So turn in your notebook, page 17. Disturbance is going to be the word they want us to think of. Elmo, come in. Write that word down. Disturbance is motion that creates a wave. Okay, so disturbance is something that creates a wave. It's the motion that creates a wave. So rain can be the disturbance, a rock can be a disturbance, a person can create that disturbance. Lots of things can create that disturbance. Or animals.
Reptiles,
Lots of reptiles in the water.
alligators, snakes.
Okay.
And sometimes spiders.
There's water spiders.
Yeah, you didn't know that. What? What is the snake? Oh,
Plastic box down here, but whoever it was, your mom.
Kayla. Sit on your butt.
I made it possible for us to have labs, not another one had.
It was anonymous.
Someone donated science supplies as parts. She said she doesn't know who, but somebody.
What would be somebody in? What would be the government?
No.
Your bud.
Copy the talking. Maya, put your computer in your backpack. Now, while we wait, we don't have ingredients on that. I need you guys to knock off your desk for this business. Don't do anything with these until I give you instructions. I just need to put some light on it.
According
All that talking, stop. Okay, so what's the term for
Something that creates motion. Disturbance. Okay, so how can we create a disturbance using this dropper? How can we create a disturbance in the water?
make the water with it. You pick up some water and drop in. and
Okay.
make it.
So the first thing you need is for your water to not be moving in that cup. That means people need to stop moving the floor, stop bumping the desk, stop moving in their chairs. You got to get that water cup still, don't you? Yeah, you got to be still. See, mine's still moving.
Yeah.
Yeah.
Going crazy.
But it says we need to create a disturbance in the water cup, like that one
Oh, can it
with the eyedropper.
now?
If it's still. Okay, you see how gently I'm pulling this water up in my eyedropper? I'm not moving my cup, because if I did, I'd be setting off all kinds of things, wouldn't I? Now, let's see if I can make this happen gently. Did I make a ripple? I did. It's not a big ripple and it doesn't last long, does it? See if you guys can make a disturbance in your cup.
No.
It's gonna, your disturbance is only gonna last a millisecond. It's gonna be fast. Okay, so you and your partners have to work together. It's not a one-person thing. You're gonna have to take turns. Bryson, you're gonna have to take turns.
Still hasn't stopped.
It's still moving.
Bryson, pull up your mask. Pull up your mask. And let someone else have a turn too, because you've already had a turn to make a disturbance, right? Try it and see if you can see the disturbance. I can see it from the side. You see it? You can see the ripples going out, especially if you look from the side. Now you draw off water and see if you can make it happen. Draw off water from the cup. There you go. It's easier to see from the side than it is from the top, isn't it? Okay. So table one, everybody was able to get it. Has everybody had a turn at table two? Okay. You can see it easier from the side than you can from the top, can't you? It's hard to see because it's fast, but if you look from the side of the cup, it's easier to see than from the top. Now, my book said to give you guys paper cups to use, but then you wouldn't be able to see it from the side. That's why I said it's so nice that someone donated all these supplies to us, and we don't know who, because they donated clear cups. Because these clear cups are way better than paper cups. Because I have paper cups of my own, but these are better. That's why when I found these last night, I was like, yeah, I had to go out and buy anything for once. Anything I can get for free, yeah. No, we're not doing so. All right, has everybody had a turn to try to make the disturbances?
Yes, ma'am.
Everybody's had a turn with the eyedropper?
Yes, ma'am.
Okay. The disturbance doesn't last long, does it? And it's hard to see because it literally is a fraction of a second. Imagine how much fun this is to be Sean. He can't sit still for a fraction.
It's so difficult to make it.
It is. You can imagine me getting my 1.5-year-old granddaughter to do this. Putting sandals on her last night. She kept them off and throwing those. Because they go between her toes. She doesn't like that. It's the first time she's ever had sandals that go between her toes. She didn't like the feeling. So she kept taking them off and throwing them. Hard-headed. She gets it from her mama, her daddy, and her grandma. That's quite honestly. All right, has everybody had a turn now? Okay. So what did we observe?
Disturbance.
We saw a disturbance. Did everybody see a ripple? What was the ripple coming from?
Movement and
Movement of what?
water.
Water. So when the water hit the surface of the water, it moved out, didn't it? It moved out in circles, right? And the reason it was going out in a perfect circle is this cup is a perfect circle. If this was an oval, it would start out as a circle, but then it would take on the shape of the cup. It would be weird looking. I don't know how to go. What does one ripple represent?
Disturbance.
It's a disturbance, but is that like a small wave?
Yeah. Like a wave pool, like in a wave
It would be a small wave moving in the water, wouldn't it? It's just that this isn't like a lake or an ocean. It's just a little bit cup of water. That's all it is. All right. What is the limitation of this experiment? We're not moving desks. Each table has a cup of water on it. So this is not a day to move desks. What is the limitation of this? What are some limitations? It says in my book, we can't see through the sides of the cup, so we only see top down. We can see the sides of the cup because this is clear. So we can see the ripples on the sides, which helps us. But is this a large lake so we can see the ripples really spread out?
No.
It's really small. If this were much larger, we could really see the effects of a ripple, right? We can't really see much of the effects of a ripple because this is so small. Yes? If I use those big plastic containers over there on the floor, you could probably see the ripple effect much better. Right? No. Would you please let us stay on track of the lesson? The fact that this is so small limits the experiment. So that's called a limitation. Does that make sense? Okay. So the fact that we can see this from the side allows us to see the ripple better, right? So that helps us. Now, we're going to go to page 17 in our notebook. Draw a line down the middle. Do it carefully because you do still have that cup of water at your table and your eyedropper. Label one side top view and one side side view. Okay, top view and side view. And it was supposed to be that you guys were imagining what the side view looks like, but we don't have to imagine because we're using clear cups. We can see what it looks like. Okay. So top view, one person draw up some water and drop a couple drops in. And I know it's fast, but oh, can't stand those bells. I know it's extremely fast. I'm going to try something. I have some dye. I'm going to drop in dye in mine and see if that helps.
Dye? You said dye?
Dye.
Color dye. Oh, there's no color dye.
Guys, right now I'm turn around here.
It's just food coloring.
He's late. He's late.
There he is. Okay. Again, this is only to see if we can better visualize this.
Can everything.
Okay. Buzz. Okay, let's see if we can see the ripple any better now, okay?
You should try red.
I'm not putting in another drop because it'll make it harder to see. Okay, I kind of can. So I think if we took a picture and slowed it down, it might be easier to see. Let me try that. I can't do video, but I can do a picture. Let's see what I got. Not what I need. Did not get what I need. See if that got it. Good idea. That was a good idea. Skiuna's comment, keep holding it, was the best one. That's about as close to a ripple shot as I could get. Oh, it worked.
What? You look like a surprise and Miss Vanderbilt over.
Yeah. No, you can kind of see the ripple.
Even though it's not even blue, it's like one drain.
So it does kind of look like a drain. That would be where the ripple's going in. That would be like the disturbance, right? Isn't that what that looks like?
Yeah, kind of. It looks like a dog's face.
Stop trying to be funny. Remember how that worked out for you on the test? That would be where the disturbance is right there, isn't it? That's where the drop went in. Kind of does. Oh, this is a better one here.
Oh, you can see it. Looks like there's just one in the middle there, one like far around.
It does.
It sort of looks like when you drop it. It sort of looks like the drop is going in it and then it's coming back up.
I'm gonna draw two different ones. That way you guys can choose which one. It's fine. Either one you guys choose. Okay.
We have to drop both of them.
What did I just say? Okay. That one's actually a better ripple picture there. This one looks like a smiley face. It's communicating with the Elmo. It's the RFID chip, radio frequency ID. You can see it because the Elmo's picking it up. Our human eye can't see it. See the flashing yellow light? RFID. We can't see it on the phone.
Wait, do it? Is it working? Is it doing it?
Yeah, it's doing it. The Elmo sees it. It's communicating with the Elmo. If you walk in a room, it communicates with electronic devices such as TVs. That's why they personalize your advertisements. Yes, it is.
They got their own Wi-Fi as electronic.
Yes, it is. All right, has everybody drawn their top-down view?
Yeah.
Okay, so now we're going to try to draw a side view. It says what we think it looks like from the side, but we have the advantage of having a clear cup. So we can actually see what it looks like from the side.
That's weird how to make that. That's like.
So you're going to have to get your head down parallel with the cup to the water level.
Actually looks like the cup is upside down. It kind of looks like it's like gonna fly up. The water's gonna like.
Kind of looks like it's in the ship.
Water, it might drop. Yeah, and it looks like it's gonna come back up. No, and it makes it look like something.
Oh, let me turn this off. Sound.
It makes it look like the droppers are big. You have to. It makes it look like there's like upside down water. Oh, really?
Yes. Ugh. Somehow I don't think that's what I'm supposed to be getting out of it. It's supposed to look, according to the book, like this. It's supposed to look like ripples from the sides, so kind of like a wave coming in from the ocean.
Well, I've been
Yeah.
trying to draw a weird circle. But when you got clear water,
Waves.
it doesn't look like
Mine look nothing. Well, I guess that sort of looks like it. Look at the waves on that one.
I was trying to
That
make
one
a
looks
whole-
sort of like waves.
I was trying to make a weird looking curve, so it looks like actually look at it. Look at it.
When you
upside
drop the
down.
water in it, you can see like the water droplets going down inside of the water.
And it looks like it's about to come back up.
That one looks sort of like waves, I guess.
Look at it upside down. Yeah, look at it upside down.
Okay, so there's side view. It looks like some gentle waves.
I think it's bubble. It pops the bubble. I'm gonna pick up
On your bottom.
give me the bubble. Dang it.
What is it?
It's a plate. I mean a bowl.
Something.
Look.
I wouldn't put that on top of the.
Yellow. Yellow. Red. Yeah, red.
Blue is
Yep, green, blue, green.
Look, doesn't that make yellow?
Makes aqua.
Yeah.
I do too.
It looks like cyan.
I'm not
Cyan is.
Yeah, that's what aqua is. Okay, so let's see if we can get a side view on this thing.
What is that?
That was going to be
Ugh.
I knew. You can see the side view from right here.
Stop moving.
Actually, I actually seen it. That's a lot of color.
It is. It takes a bunch to get it.
You can just
Go
hold
away.
your finger down on the camera gun and you'll get a bunch of them.
That's what I was doing.
No, I mean like hold your finger down and not look at it.
It turns into video when I do it.
Like you got it.
Okay.
Are there any?
This one might be.
That looks nice.
That looks kind of like a wave, doesn't it?
That's why I chose the book.
That one looks more like a wave, doesn't it? That's kind of what it's supposed to look like, is waves. So that's about as wave-like as you're gonna get, I think. Okay, so that's your side view. Make sure you label this as top view and side view. Okay. Was everybody, when you were trying to do your side view, could you see some waves? I know it's harder to see. That's why I had to try it with the square bowl to see if I could get it with my camera. Please stop moving your desk while we have water cups out, okay? Oh, look, that one actually is a good picture with waves. Would you stop with the desk? Okay, this one actually, in the series of 40,000 pictures it felt like I took, actually got some pictures of waves in there. Okay, so we got our individual top view and side view. Now, it says create a class wave drawing comparing to the person beside you. Well, I'm guessing we all have very similar ones since I was drawing mine up here at the same time you guys were. Side view drawing. Do some people's drawings look more squiggly than others? Look around at people around you. Some people's look more squiggly, some people will look more wavy.
Hers was better than my first one.
Mine looks like a smiley face.
So this is what they want me to show. I can do this without spilling. If I can get through the day without having a soaked table, I'll call it a win. A wave is a regular or repeating pattern of motion. So let's write that in our book. Where it says name, let's put wave up here. Wave, yeah, our name, all of us are named Wave today. Wave is a regular or repeating pattern of motion. Okay. Yes, the date is motion. Our name is Wave and our date is motion.
So your name is Wave Wave Driver.
climate is wave motion.
No matter which way you like do the direction, it always makes the same motion.
Okay, so if you notice these waves, they don't go very tall, do they?
No.
Because we were just using a little eyedropper. Empty out your eyedroppers, please, into your cup. So your eyedroppers are empty. Put the eyedropper on the table next to your cup. And then don't bump them. Okay? So a wave has a height. Look around at the other people at your table. Do you have a different height to your wave than your people at your table? My waves don't have much height. If it'll come in, Elmo, come in. My waves don't have much height at all. Okay, my waves are short.
My waves are a bit high.
My waves are not taller when my waves be like waves on waves on waves.
All the way around.
Okay, first of all, our class view, class drawing.
My waves be waves on waves. My waves be waves.
So top view. Side view.
Stop singing up there.
I'm gonna do it in blue because that's how mine was. How do y'all want me to do the top view? Do you want me to make it look pretty? Like nice concentric circles or more weird like what mine looked like up there?
Pretty.
Make it look like a clown.
No, like perfect concentric circles like this? Is that enough or do you want me to put another one? Okay.
Make it ugly, like squiggly.
Okay, so there's our top view. Now, what about the side view? Do you want it to be tall waves or flat waves like that? No, tall waves. Like that? Okay. So side view. Make those first sounds. Maybe get a thinner pin for these other things. They expect teachers to have all different kinds of stuff.
Hey, that's okay. Just a little pencil. No pencil, no.
So there's a still water line, which is a line that goes through. Oh, and I didn't quite get this right.
Shut up.
Oh, part of my drawing is supposed to be more like this for a wave. Okay. Yeah, it's supposed to be a more soft wave. Okay. Yeah.
That
Really.
way.
And then it says this would be the still. Like if there was no movement going through, that would be the still. Like if it was totally still.
We
There's
almost
no wind, no disturbance or anything. That would be the still water line. Everybody understand that? Okay. So they want you to draw something like this, because you still have plenty of room in your notebook. And then add in a still water line. everybody do this.
Done.
Okay. I'll get a picture of this for my friends online.
Actually, do this. Okay, so for my friends online, I need you to draw this. Bless you.
I'm like 8. My child's like little 8.
Okay, so you need to draw this in there, okay? Let me zoom in a little bit. I don't know why Elmo's not giving me good contrast today.
Okay. Okay, so using a bigger tank, like those big things there, would make it easier for us to see the side view, right? If we used even a bigger tank, like a 75-gallon fish tank,
Like that.
it'd be heavy.
Yeah.
That's kind of got some expensive stuff in it though, and a lot of holes. But if we used a big tank, it'd be even easier to see that side view, and we could have better waves, right? Wow. All right, so go to the front of your notebook. You have a picture on the very front of your notebook.
This?
Yes.
Oh,
It is waves. That is a painting called Swift's Paths of Movement and Dynamic Sequences. So Swift's is the name of a bird,
When we first got it, I was like, why is this like that?
right? Dynamic means movement. Okay, so Swift's, that's kind of bird. Dynamic means movement. Sequences just means stuff put in order. So if we take that name, it literally means birds, passive movement. Why are you playing with the eyedropper? I said empty the eyedropper into the cup and then put the eyedropper on the table next to the cup. Not following directions, my dear. So it literally means birds, passive movement, and changing pathways or changing pieces of movement. Okay? It's by Giacomo Balla, so it's an Italian painting. Okay? Look at it.
I don't understand it.
Okay? And that's fine. It looks like abstract, doesn't it?
Yeah. To me, right
I personally don't see birds in it. What do you see?
I see it right here. It looks like boats.
I don't.
It looks like boats, okay? What else do y'all see?
A golf club.
A golf club? Where do you see the golf club?
I see a bird.
I gotta take
Colors.
I see flowers. I see a flower.
Okay, hold on, hold on. Where do you see the golf club? What color is it?
It's a big thing in the middle.
What color?
Upside down. Purple. I see a pancake.
I'm still not seeing a golf club.
But now that I'm looking upside down, all of these are like birds. When you turn it upside down, the waffle's right there. I see penguins.
I see fish scales.
Oh,
Lots and lots of fish scales.
You see it right.
I see a whole lot of fish scales.
I see a car. I see a car. I see penguins. I see a car.
Yes, I see penguins all over the bottom.
And I think it's the bird.
A bird what?
I see a fish. I see a car. I see 2 fishes.
I see the birds now, sideways.
I see 1 car. I see the fish. There's a million of them. There's a
I
lot.
see fish scales. Scales
There's a
everywhere.
million fish at the bottom of the one right there.
No, that's pink. I've seen scorpions too.
You see big what?
I see fish bones.
Yes.
Snake. That's
Fish bones where?
Okay.
How do you know fish? I see tadpoles.
Does anybody see what looks like waves?
No.
Yeah.
No.
They're light yellow, right?
Yeah.
The waves are light yellow.
That's what I'm told.
We can see on the bottom. I see them. What looks like penguins
Yes.
marching.
Yeah.
You see birds on the right-hand side going towards the middle, look like they're flying.
Yeah. The whole squad of them. Look, there's a snake right there. That's the body, then that's the head. Oh. See it?
Where?
Oh, right there. You have to turn it upside down. I still.
Talking about right here.
Yeah. I see a shoe.
Can I ask some questions now? All right. The curves in the
It
painting,
needs to be upside down.
they move up and down, yes? Is that similar to the drawing of the waves from the side? Do the curves in the painting, are they as regular as our curves, or do they kind of go all over the place?
All over the place.
They're not as regular as ours, are they? Ours are more regular. These, it's like the artist had fun making it, and we were trying to be more pattern-like, more scientific, right? Okay. Some of those smaller curves seem to zigzag all over the place, don't they?
Yeah.
But our wave, we just drew one wavy line, right? This almost looks like you use some kind of math algorithm with art, doesn't it? Have you seen those math pictures where they use a computer program with math formulas? This almost looks like that. And then you add a paint to it afterwards. It almost looks like a math algorithm. But it looks very abstract. I'm not,
Snake too. You can.
I like art, but I'm not much into abstract. So I'm just gonna leave it at that. I mean, that's about as abstract as I get. Those are fun,
You
making.
can see the whole snake.
But those have a point. That's supposed to be like the,
That is not a snake. Some snakes have
page.
I've seen a bunch of snakes. That's
And they
not a
blow the
snake.
rays.
I've seen it's not a snake. I've seen a pink snake. I haven't seen a thing. I've seen a bunch
Funny,
of
it's
snakes.
black, white.
It's not a snake. I shot the head.
Okay.
It's not a snake.
Let me read to you what they have to say, what the artist has to say about that painting. Bala, who's the artist, one of the founding members of Futurism, spent much of his career studying the dynamics, which means changing, of movement and speed. Inspired by photographic studies of animal locomotion. So in other words, you know how I was taking a lot of photos trying to get the movement of the water? That's what he was doing. Fast photos of animals moving. That's how he got this. Lots of photos, fast photos of animals moving. And he put them together to make this.
When I first had it, I was like, what does it look like?
Inspired by photographic studies of animal locomotion, such as those used by French physiologist Etienne Jules Marie, Bala created an image of motion pushed close to abstraction. Here, Bala looks to science to establish a new modern language for painting. So it would be like him taking a series of pictures of a person walking. Please don't do that. Him taking a series of pictures of a person walking and pushing all those photos together to make a single painting. He took a bunch of pictures of birds flying and pushed them together into one painting.
at the top it shows like a big old splash of water, but it's orange.
So then what's that brown thing? Not sure, but this is a bird flying.
And
One
it's a
single bird
snake.
flying.
It's a snake if you turn it upside down. You can see it.
And those I really do think are penguins walking.
And there's some fish.
And
I mean, not
So those are definitely animals moving. That's animal moving. Okay? In both science and art, sometimes you draw a simple picture of something real. Like our wave drawings don't show all the details. We just made a snapshot, a very simple snapshot. The picture that we were trying to take over there was based on more realism. This is just a real simple snapshot, right? He was taking something and putting a bunch of images together to try to get something like realism showing movement in a painting. Because paintings you see are a moment in time, right? He didn't want a moment. He wanted to show motion. He wanted to show several moments, maybe several minutes in a single painting. He had a different intent in his drawing or his painting. He wanted to show things like speed and direction. Scientists often use measurement to describe motion. Artists usually aren't measuring things like speed, but he was. My kind of artist, mixing science with art. I run science and art together.
Where was this picture made?
Doesn't say. Oh, 2009.
how much money did he make off of it?
Don't know.
$1.
No.
Really?
Okay, so first things first, let me pick up your cups of water and eyedroppers.
Yeah,
I don't know right now, pick up cups of water and eyedroppers.
That was fun. Today was fun. Worst part of the day is by the time that we go to sleep, it was the episode on sit. Yeah, upside down it looks like a snake.
Okay, that's everybody's water? Okay, I need to see everybody's notebooks, so I can grade them real quick. And I do need the talking to stop, guys. You gotta open it.
Can we check the one with the show?
I know you're too.
Guys, you need to label that line, the still water line.
Oh, I already did that.
Draw that other line. Draw, still water line.
I just want to go.
I don't know.
I don't care.
Still water line. Oh, Laura, let me get your cookies. I need those too.
It's very bad.
Mine kind of looks like a smiley face. I meant to do it better, but mine's horrible. Mine's worse than yours. I gotta open mine. I gotta open mine.
Okay, innocente requires
Ricardo, starting your test. Pull out your computer and starting your test.
I did it.
You did it last night? Ricardo, you done your test? Too busy. All right, guys, you have 15 minutes. You may work on Zern. Let me pass out your diagnostic if you haven't finished that.
Yep, that's what I did. Oh, I think
I do need the talk to stop so I can input grades and I can grade people's tests. That means stop talking. All that talking needs to stop. Leah. Wow. I don't know how you're even gonna make up your Melanie, not if she looks on yours. You know, I mean, to get the points for the actual doing of the lab. I know you don't understand what desks or where they are. Stop the talking. Okay, Megan and Jackson, that's the end of today's. Just submit pictures to me. Your notebook needs to have the definition of wave up here and disturbance. Your top view and your side view, including the still water line labeled. Okay. Got all of it, Megan?
Bye.
All right, bye, babe.